Alrighty, calculates, we're ready to do the second fundamental theorem of calculus. So I would actually like to add a slightly different version to this. So I wanted to copy this down. Okay, so I'm defining now this integral of my function to be going back to, remember we called this the mother function. And so it's going to need a capital since this side had a lowercase. Okay, so if I define this capital F of x to actually be the integral, and I decide, hey, I'd like to take the derivative of capital F of x, then I would be taking the derivative of both sides. And so, thinking process, it should probably make sense that a derivative and an antiderivative basically cancel each other out. And that's sort of true in this case if this bottom value, this bottom bound, is a constant and the top is the variable x. And notice that I am in fact plugging this in. So on these blanks here, again, note that a is a constant, and I have the lower limit is a constant, so the lower limit, in order for this to work, that lower limit has to be a constant, and the upper limit has to be x. I'll show you what we're going to do in some other cases when either that's not a constant at the bottom or the top is something a little more than x. So looking at this first example, then I'm plugging this in, and so I'll end up with just sine of x. Again, noting it follows my rule because the top is x and the bottom is a constant. Same thing on this next one. I note, hey, I can use the second fundamental theorem of calculus. I have a constant on bottom. I'm taking the derivative of the antiderivative. I just have to remember in this special case that I'm going to plug the variable in, and so I get tangent cubed of x. So far so good. Right now we're just going to make sure that you see it and then recall that you're supposed to use it. So these first few are obviously simple. Now notice on this next one, oops, they're switched. So I would like to know, is there a way I can switch them? And the answer to that is yes. You haven't had to do much of it yet, but if I switch them, it just negates the whole thing. And now I get the x on top and the 3 at bottom, and hey, now it fits my rule for second fundamental theorem of calculus. And I'm going to plug in the x. So I'll have negative 2x cosine x. Not so hard. See if you can try the next one by yourself. So now notice, again, I have a constant at the bottom and x at the top. So I'm just going to plug x in for the variables. So I'll have minus sine x over 3 plus cosine x. We're just trying to scare you a little bit, see if you still recognize that pi over 2 is in fact a constant. Okay, so now what happens when it's not? So now note up here at the top, I don't have just an x, but I have some function of x. So when that happens, we have to use the chain rule, which is, I'm going to plug it in. So I'll have f of g of x, here it is. And then I also have to take the derivative of that top piece. And so here this is. So we're going to skip down. All of this is just another way of restating that. So I plugged in u. Here it is. f of u, sorry. And then I took the derivative. Okay. So let's look at some examples.